Today we are going to see how to solve trigonometric equations. So here basically in trigonometric equations we have unknown angles for which the values of sine, cos, tan and other trigonometric ratios will be given, and we'll have to find out the angles which will satisfy those relations. For example, if we take simple examples like sine theta is equals to 1 by 2, that means that this theta is equals to pi by 6. Same way, if it is cos theta is equals to 1 by root 2, that means this theta will be pi by 4. Same way, if tan theta is equals to 1 by root 3, that means theta will be equals to pi by 6. Now these solutions for theta are actually not uh, the only solutions. For example, this sine theta may be 1 by 2 not only for theta equals to pi by 6. So if we see the function, the graph of sine, so sine graph is like this. So this means this value half will be actually at two places. One place is this, which we just now got, that is pi by 6, and another will be this point. This point we don't know right now. Okay, but we can find it very easily. See, we know that on this 0 and pi, that means if we are going to do pi plus minus theta, the ratios are not going to change, but the sign will change. Okay, so we know that sine pi plus theta will be minus sine theta. Why minus sine theta? We know whether the ratios are going to be negative or positive using this figure. So in the third quadrant, sine is negative, so that's why this is minus sine theta. And same way, sine pi minus theta will be equals to sine theta. So that is one such scenario. Next, for cos pi plus theta will be minus cos theta, and cos pi minus theta will also be minus cos theta. So when we are going to get positive cos, so that will only come here. So cos 2 pi minus theta will be equals to cos theta. And this we can actually see in the graph of cos. So in the graph of cos, this is the cos graph. So you can see that this is 0, this is 2 pi, and this will be pi by 2, 3 pi by 2, sorry, pi, this one is 3 pi by 2, and finally 2. So for positive values, we see that if this is theta, this will be 2 pi minus theta. For negative values, we see that one is pi plus theta, and another is one is pi minus theta, and another is pi plus theta. So this is how we actually find the values of theta which will satisfy these given equations. So for example, here if I have to find tan theta is equals to minus 1 by root 3. So we know that tan is negative over here in the third quadrant. Tan is positive in the third quadrant. Everywhere else it is negative. And in the second and the fourth quadrant it will be negative. So for second quadrant, I can say that tan pi minus theta is equals to minus tan theta. And we just now saw that tan theta equals to 1 by root 3. The acute angle or the basic angle we know theta will be pi by 6, right? So that means if theta is pi by 6, our work is done here. So if theta is pi by 6, so we have tan pi minus theta is equals to minus 1 by root 3. That means this particular value here, which we have to actually find, is pi minus pi by 6 or 5 pi by 6. So this is how we find these basic values. So these values which come between theta values which come between 0 to 2 pi, they are called principal solutions. Okay, but we know that for a given value there may be multiple uh, candidates of theta. So in order to find that, we also have to have general solutions. Okay, so next we'll see how to find these general solutions. So in order to find general solutions of trigonometric equations, first we'll see few very basic formulas for 0. That is, if sine theta equals to 0, this is possible when theta will be pi or 2 pi or 3 pi. So general solution will be n pi. We know that sine theta is 0 over here and here, and cos theta is 0 here and here. So at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, cos theta is 0, while at theta equals to 0, pi, 2 pi, 3 pi, 4 pi, that is the sine theta is 0. So sine theta is 0 means theta is n pi. Same way, cos theta equals to 0. That implies that theta is some odd multiple of pi by 2. So that can be written as 2n plus 1 pi by 2. Same way, we can also find it for tan theta. And we know that wherever sine is 0, cos is not 0. And at that place, tan theta will be 0. So if it is given tan theta equals to 0, so that means theta is equals to n pi. So basic, these are the general solutions for 0. That is, if sine theta is 0, theta is n pi. If cos theta is 0, theta is an odd multiple of pi by 2. And if tan theta is 0, that means theta is any integral multiple of pi or n pi. Next, we are going to see how to find general solutions when these values are not 0 and it may be some specific values. For example, if sine theta is given to be equals to sine, say, alpha. So in that case, we can actually rewrite it as sine theta minus sine alpha is equals to 0. And by applying this identity, we can say that 2 sine theta minus alpha by 2 into cos theta plus alpha by 2. So this can be rewritten like this. Now we have two products and the whole product is 0. That means this part or this part, any one of them or both of them are actually 0. Okay, so we write them separately and solve them separately, and this thing we have already seen. Sine of theta 0, that means theta is n pi. So from this part I can say that theta minus alpha by 2 is equals to n pi, right? And from this part I can say that theta plus alpha by 2 is equals to 2n plus 1 pi by 2, where obviously these n is actually an integer. So from this we have to actually find theta. So this theta is nothing but 2n pi plus alpha, right? And here this theta is nothing but, if this is 0, that means theta is nothing but 2n plus 1 pi minus alpha. Okay, so now if we have to find uh, what actually happens here, so we see that if it is 2 and pi, that means it's an even multiple of pi. So when it is even multiple of pi, we are adding alpha, and if it is odd multiple of pi, we are subtracting alpha. So this can be combined to rewrite as theta is equals to any multiple of pi, right? But we may have to add or subtract based on whether this multiple is even or odd. So if it is even, we are adding, and if it is odd multiple of pi, we are subtracting. So that's why we'll just write minus 1 to the power n. So what does it do? Minus 1 to the power n becomes minus 1 if n is odd, it becomes 1 if n is even. So this becomes n pi plus minus 1 to the power n alpha. So this is our solution when we have questions like this, that is sine theta is equals to sine alpha. So for this, the general solution is theta is equals to n pi plus minus 1 to the power alpha. Now question is how we are going to solve this, or how we are going to use this. So I'll also give you an example, and then we'll move to next problem. So for example, I may have question like 2 sine theta plus 1 is equals to 0. I'm choosing a little trickier question. So 2 sine theta plus 1 equals to 0. That means sine theta is equals to minus half. Now we have to find what is the first angle between say 0 and 2 pi, where we find sine theta as minus half. So as I said, sine theta is negative first in third quadrant. So that means there is some sine pi plus theta which is equals to minus half, uh, or we know that this will be minus sine theta minus sine theta, which is equals to minus sine, and we know that when is sine theta half? Sine theta is half when theta is pi by 6. So this is the common value. So that means this theta is nothing but pi plus pi by 6, or 7 pi by 6. So this particular equation can be rewritten as sine theta is equals to sine 7 pi by 6. So now we have this equation in the form of sine theta equals to sine alpha. So this is theta, this is alpha, alpha is known, theta is unknown, and this is the general solution. So directly we can apply general solution, that this will be n pi minus n pi plus minus 1 to the power n alpha, that is 7 pi by 6. So this is our general solution for the given equation, which is over here. Now same way, just like we have proved for sine theta equals to sine alpha, same way we can also prove for cos theta is equals to cos alpha. So again we can rewrite it as cos theta minus cos alpha equals to 0, and then the formula for this, that is minus 2 sine theta plus alpha by 2 into sine theta minus alpha by 2 is equals to 0. That means either this one is 0 or this. So if sine theta plus alpha is 0, that means theta plus alpha by 2 is n pi, and if theta minus alpha by 2 is 0, that means theta minus alpha by, sine theta minus alpha by 2 is 0, that means theta minus alpha by 2 is equals to n pi as well. So from here I get theta is equals to 2n pi plus alpha, while from here we get theta is equals to 2n pi minus alpha. So this is actually 2n pi even multiple minus alpha, odd multiple plus alpha. So this can be simply written as any multiple plus or minus alpha. Both will be the values. So the final solution which we have is theta is equals to 2n pi plus or minus alpha. Now take an example to understand this. So say for example root 3 sec 2 theta is equals to 2. So I have written root, and our question is sec 2 theta, our question is cos. The theorem was about cos. So we know that there is a relation between cos and sec. Sec theta is equals to 1 by cos theta. Okay, so that means we can say that cos 2 theta will be equals to root 3 by 2. Okay, and when is cos, say for example, when is cos x root 3 by 2? So we know that cos 30 is root 3 by 2. That means this is nothing but cos pi by 6. So I can rewrite it as cos 2 theta is equals to cos pi by 6. So now our question has come to this format, that is cos theta equals to cos alpha, and we know that in that case the given value theta is equals to 2n pi plus minus alpha, so plus minus pi by 6. Obviously we don't have to find this, we have to find theta. So this theta will be equals to n pi plus minus pi by 12. So this is our solution. Similarly we can find for tan theta. So say tan theta is equals to tan alpha, this means tan theta minus tan alpha is equals to 0, or we can say that sine theta divided by cos theta minus sine alpha divided by cos alpha is equals to 0. So that means sine theta cos alpha minus sine alpha cos theta is equal to 0. Denominator, if it comes to right hand side, it will become 0. So this is nothing but sine theta minus alpha is equals to 0. Okay, so now it has changed to sine form, and we know that for this we have theta minus alpha is equals to n pi minus 1 to the power n. Sorry, that means theta minus alpha is itself is n pi. So that means this theta is n pi plus alpha always. Now we have seen formulas, we have seen equations involving only sine, cos and tan. In the previous problem we have already seen that if the equation was having sec theta, we didn't have any separate formula for sec theta. That's why we changed sec theta to cos theta, and then we solved the problem. So finally we have only three form of equations here which we should know how to solve. That is, sine theta is equals to sine alpha, or cos theta is equals to cos alpha, or tan theta is equals to tan alpha. And the solutions for this will be theta is equals to n pi plus minus 1 to the power n alpha. For cos theta, this is theta is equals to 2n pi plus or minus alpha, and for this theta is equals to n pi plus alpha. So these are the three basic theorems which we should know in order to find some general solutions of trigonometric equations. Thank you.